What up, class? Part 3 of integration by substitution. Obviously, we got part 1, we got part 2, we got part 3. This is big time stuff. It's obviously really, really important, okay? Now, here we go. You actually crazy. But some AP teachers say you need to know all those things. That's crazy. Do you know the antiderivative of all those? You should know a good number of them, but hurry up. Hit pause, write them down. All right, I got all the solutions right there. Okay, now listen. The only really ones that I'm going to make you know in class for AP Calc because they come up is really sine and cosine. Okay, but you should be able to create the tangent and cotangents. And the other ones are just cray-cray. All right, so I'm not going to make you worry about those. Okay, but do write them down. So hit pause, write them down. I'm going to go off the screen and we're just going to get after it right off the bat. Okay, so the other two that I said you needed to know would be the tangent and cotangent. But believe it or not, we can create those. Okay, and we're not going to create all these. It just gets really tedious, and you do a lot of that in your Calc 2 class, all right? So here we go. How do I create these? Well, believe it or not, tangent is sine x over cosine x, okay? And then believe it or not, we just do a little u sub, right? What would we do here? We would let u equal cosine x, okay? And if I let u equal cosine x, du equals negative sine x dx. So that means dx is equal to 1 over negative sine x du. So remember, we sub. Now, why did I make u cosine x? Try making u sine x and see how it causes a lot of trouble. So I'm going to keep the sine x. I'm going to put a u where I put it, which was down there. And then we're going to go times 1 over negative. Oh, sweet. That's why it worked out. Booyah, booyah. I'm going to bring the negative on the outside, and then I get 1 over u du. Now, what is the antiderivative of 1 over u, right? That's negative the natural log of the absolute value of u plus c, right? Because it's an indefinite integral. Let's plug that c back in. And there you go, right? Class, actually not too bad, right? And that's one of those I said you needed to know from the previous page or the previous notes. I hope you copied them down. Now come on. Get successful in this class. How do you get successful? When I say to try things on your own, try them on your own, right? Try them on your own. Okay, so try cotangent on your own right now. Okay, hit that pause button. I really hope you tried it. If you did, then you are just the best. And that's how you get good in this class, right? Trial and error. And now I'm going to show you what you should have done. And hopefully we all did the same thing. I'm going to let u equal sine x. Why? Because it's in the denominator. And when it's in the denominator, I find out that, hey, we can cancel some things out. We can get rid of all of the x's. Whoops, that should be a du. Boxy, boxy. And then we get equals the integral cosine of x. This time u was sine x. So that gets replaced, and so does the dx. Sweetie, sweetie, right? So I get the integral of 1 over u du. What's the antiderivative of 1 over u? It's the natural log of absolute value plus c, right? Because it's an indefinite integral. Now let's put that sign back in for my u, and I am done. See, so I don't even have to have those memorized. It's cool. You can do them on your own, right? And then there's actually proofs for all these other guys. But you know what? Don't worry about it unless you want to get a little crazy. And then you just have to use a lot of identities to get them. Okay, these here you have to be concerned with in this class, all right? And these are my favorite because they're like puzzles. Okay, now what do I mean by a puzzle? Well, if you look at this problem right off the get-go, this problem, I'm trying to get off that. There we go. This problem here, oh snap, it kind of looks like a u sub, but that u sub gets me nowhere. Okay, or it actually causes more trouble. So in terms of it, it kind of gives you a hint there, inverse trig, is that kind of should look like something. Okay, and what does it look like? That kind of looks like inverse sine, because the derivative of the inverse sine is equal to 1 over the square root of 1 minus x squared, right? Those kind of go hand in hand. And that's what it kind of looks like. So now what it is we're gonna do some work. Okay? No magic allowed. We're gonna do true, legit work. And it really looks like that, and I could even rewrite it like this, and oh, it even looks more. So what I need to do is I need to make this look like this, and if I can, I could just say, hey, that's inverse sine, done. Okay, so that's what I have to do here. Now, how do I make it look like it? Well, first off, you focus with that number right there. That needs to be a what, class? That needs to be a 1. So guess what? Let's get rid of it. Let's get rid of it. How do I get rid of that? Well, I could factor out. I could factor that 4 out. And if I factor that 4 out, I should get something that looks like this. Now, if I take that 4 out of this, remember, factoring is like division. So it would be like x squared over 4. You guys kind of with me? How do I know that's legit? If you, what the what? Hopefully you said what the what. Make that a 1. Okay? If I distribute that 4 back in, I get my original. So it means I'm good to go. Now, believe it or not, you see that 4 there. I actually see a square root of 4. What's the square root of 4, class? That's 2. Where is that 2? That's in the denominator, and that is a constant. So that's my next step. Okay, and these are awesome problems. I just love them. Okay, and I get that. Okay, whew. Well, I got closer. That kind of looks like that over there, right? Class kind of does. But here, I just need that. Well, let's do a little u sub maybe, right? And I'm just going to say, hey, I'm going to let my u, and you know what? Let's make that u squared. What do you guys say? I'm going to make that u squared. I'm just going to put a u squared there. Okay, and I'm going to make that equal to x squared over 4. So guess what? I'm just going to come over here and I'm going to, as long as I say let, it's legit. I can do it. So that's going to be 1/2 the integral of 1 over the square root of 1 minus u squared. Oh, sweet. I totally have that. But that's a x that turned into a u. I just can't put a dx there, right, class? I have to substitute that du in. Well, how the heck can I do that? Well, let's see. Oh, shoot. Let's just take the derivative here. But before I take the derivative, let's make it even more okay, right? Let's just take the square root of everything. And that means u would be x over 2. Well, that means du, the derivative would be just 1/2 dx. And if I solved for dx, I would get 2 du. So let's go ahead and substitute that, right? The dx usually would go there. Let's put that. And then what can I do with that 2? That 2 is a constant. I can bring that all the way out front. And then I get the integral of 1 over, right? That 2 crosses out, booyah, booyah. And then, oh, are you serious right now? That is exactly what I wanted. That means that antiderivative, that's beautiful. That's what I wanted. That's inverse sine of u plus c, because it's an indefinite integral. Am I done? There's no way I could be done because the original problem had x's in it. And if the original problem had x's in it, my answer better have x's in it. And what is u? It was what the heck? Oh, u was right there. It was x over 2 plus c. Done! Oh my gosh, could I possibly have gotten that really, really tough problem right? I know you guys are waiting for me to get one wrong. But I got it right. All right, here we go. Let's do the next one. Boom. Booyah, booyah. Here we go. All right. Oh, snap. That is just really tough. And it kind of looks easy because I could just do this and then du equals 8x dx. But then oh my gosh, when I solve for that, I get more x's on the bottom and they don't cross out. So I don't want to do that. But that kind of looks like something. Even though there's not an absolute value, that looks like inverse secant. So let's go ahead and write down what inverse secant is equal to. It's 1 over the absolute value of x, boo, x squared minus 1 dx, and that would be inverse secant, right, class? Plus c. Oh, I forgot the plus c in the one before. I know some of you are saying that, but I caught it. All right, here we go. All right, so how the heck do I make this look like this? There's no way that's impossible. Well, let's see. What did I tell you last time? Start with that guy. There's a 1 there and there's a 9 there. So let's get rid of that 9. How can I get rid of that 9? Well, I can factor out a 9. Well, how the heck do I factor out a 9 out of all that stuff? Well, that means a 9's going to come out. And if a 9 comes out, that means, remember, it's like division. So I'll get 4/9 x squared minus 1. Should I check to make sure I'm right? I should by distributing that. And I end up with that. So that means I'm good to go. Now let's go ahead and work with that. Well, that's the square root of 9, which is 3. And since that's multiplication, I can pull that out. So I get a 1/3 on the outside. Oh, sweet. I'm closer to what I want, right? I'm really close to what I want. What is messing it up is that bad boy right there. And what, well, let's just cheat a little bit, right, class? I want that to be just a u squared. So let's let u squared equal 4/9x squared, right, class? And then let's go ahead and let's go ahead and do. Well, okay. You know, I'm going to take you for a long journey on this one, all right? So we all understand what's going on. You got your x there, okay? And then I get the square root of. Oh, I cheated, so I just put a u squared. Oh my gosh, I'm done. No, I'm not. I have x's and u's. X's and u's are bad. Okay, so how the heck do I get rid of all these x's and u's? Well, let's see. What could I do here? Well, okay, let's go back to this thing, right? Because we all know I got to get rid of that dx, which means I have to find a derivative. Well, let's first write what u is. U equals take the square root of everything, and I know you're saying plus or minus, but in this case, hey, we're just going to call it u. You don't need to do the plus or minus. Okay, so there's my u. So what would my du be? Well, my du then would be 2/3 dx, which would mean my dx would be, instead of dividing, I'm going to multiply by the reciprocal. Booyah and booyah. Oh, sweet. So guess what? That enables me to put the 3/2 du right there. But then I also have to substitute something in for that, right? I'll do this in the next step because there's major simplifying that needs to be done. I'm going to bring that 3/2 out in front, and then you get 1 over. What is x equal to? Well, what is x equal to? Oh, well, that means x would be equal to, multiplied by the reciprocal, 3/2 du. So I get my 3/2, not du, u, and then I get the square root of u squared minus 1. Oh, sweet, I'm almost done. Well, that's 1 divided by, well, that cancels out, right, class? So I get a 1/2. How the heck does that guy come out? Well, that's 1 divided by, so once again, multiply by the reciprocal, right, class? Woo, sweet, right? And then we get the integral. Oh my gosh, that is so beautiful. It almost makes me want to cry. But that's inverse secant. No way. And it even simplifies outside just to be 1/3 inverse secant of u plus c. And I'm done. No, I'm not. You can't have u. You can't have u. So that means I just have to resub, and I get a little 1/3 inverse secant of u. What was u? What the heck? Oh, got to go all the way back to there. 2/3x plus c. There's no way I got that one right. Holmes, right? I know you guys, you're begging. Mr. Snaka's going to get one of these right. He's going to have to go all over. I got it right. Right? Okay, here we go. Let's get some notes here. Okay, oh my gosh, part 1, part 2, part 3. Seriously? Are there really that much? And I am going to steal my notes for this, okay? So I give you guys great stuff. What do I do when I need to evaluate an integral? What do you need to do? 1, is it a memorized, and I don't like memorizing, but you have to for this. Is it a memorized formula? Okay? And if it's a memorized formula, then it's most likely an inverse trig. So that's why you have to know your inverse trigs, or you may need to do some algebra to get it to be an inverse trig, kind of like the ones we just did. Okay, 2. Do we have an inside? Do we have an inside? Whoops, inside and outside. If I do, what do I need to do, class? U sub, right? Then we have to do U sub, and sometimes there's a lot of work you have to do there. 3, rewrite the original problem with algebra. This was more part 2, right? So that was like part 1, step 2. That was part 3, and this was part 2. I guess I should have labeled these better. And if I'm doing it with algebra, we have like A. You could do long division. When do you do long division? Do you remember? See if you can tell yourself right now. If you forgot, go back and look. Part B, expand. And this part here would be all if you can't do U sub. And then part C, would be, oh, you separate, right? When you have something like that, A over C plus B over C. And then we even have a part D. And part D was complete the square. And when we completed the square, it usually got us back to inverse trig. So how about it? Part 1, part 2, part 3, we probably have a quiz coming up, right? That's some big time integration by substitution. And hopefully it was good to go. See you in class. Aloha. Remember to try the worksheets before you come in. That's how you get great at this stuff. Aloha.